Welcome to Lab Life with the Air Force Research Laboratory.
Hi, I'm Michelle.
And I'm Kenneth.
Hello, folks. Today we are joined by Dr. Kathleen Dipple to discuss the power of gold nanoparticles, alternative navigation techniques, and how important it is to find a supportive community in the workplace.
In 3, 2, 1.
Hey, folks, and welcome back. Today we are joined by Dr. Kathleen Dipple, an alternative navigation research scientist. Thank you for joining us.
Hi, it's great to be here.
So starting off, before we get into that amazing title you have and really dive into what it means to be an alternative navigation research scientist, you brought up something really cool. We were kind of talking beforehand, and that you were really into magic. So when that comes to mind, I always think like, hey, science is magic in a way. And I'm trying to think when you were younger, is that why you kind of got into magic and then eventually science?
Yeah, so I've always been a nerd ever since I was very young. I loved stuff that maybe tricked people or surprised people. And I was totally into magic. And in my first chemistry class ever, our teacher used to do these demos where there's one specifically that like blew my mind. And it was the elephant toothpaste demo, where you have two small amounts of liquid come together and it basically foams up so huge, like 30 times the size. And it felt like magic on another level to me. And I wanted to like master that. So that's why I got my bachelor's in chemistry.
No, honestly, I bring this up all the time because it's almost a running joke, but it's true. I wanted to be a chemist for so long when I was a kid because I thought it was so cool like that. Like I saw experiments as a kid or people visit in second grade, like whether it be foam or like even talking about like, hey, look at these two compounds go together, like making this compound and look at the reaction. And it was so cool to me, even looking at, volcano stuff, like mixing together, was it vinegar and baking soda? And It really is to kids like magic. So in terms of the actual magic you did then, did you actually have a magic kit or is this more of like a chemistry kit that you performed scientific magic with?
No, I just had like a cheap little magic kit that I used to love. Like I had like a dollar snatcher and I like pranks too. So I had like itching powder and, the thing that makes your thumb look like it got chopped off, all that good stuff. But actually nowadays I have chemistry demo stuff. Like I keep at all times, just even for like any kids in my life or adults. Cause honestly, I still think it's cool. So I actually have everything for the elephant toothpaste demo and a couple other demos, for my cousins or, anyone.
Have you ever done the Mentos and the Diet Coke experiment that was a pretty big thing a few years back?
Oh, yeah. You can actually do Diet Coke versus regular Coke because it'll be slightly different because Diet Coke is less dense than regular Coke because there's no thick sugar or syrup. So Diet Coke explodes better.
That's the real science we need behind us. So you guys, if you take away anything from the beginning of this podcast, that's important. So that actually begs another question that I have to know. So April Fools, for us, we're recording this just a few days beforehand. So being a prankster, is this a pretty big holiday for you?
It's huge, honestly. I've thought of ways to prank people virtually. I've thought of getting, the blood capsules in their mouth and then just randomly during a talk, like having blood start pouring out. But people are high stress right now. Maybe that wouldn't be too funny. But yes, let's just say I'm planning a couple things.
I would love to hear updates because honestly, so I was always, I guess, the pranky, you could say. Like I was never the good pranker, but my sister, much like you, she was dialed in. She knew how to get us. Like whether it was toothpaste and the Oreos, making the Jell-O and make it look like it's cranberry juice. Like it was never anything, like it was always fun like that. Like very tongue-in-cheek, funny stuff, but virtual stuff I didn't think about. That's a real challenge. So I'd be interested to hear what you got.
Yeah, I got a couple ideas. Maybe having a fake burglar come in and like, you just...
It almost sounds like a prank show.
Yeah.
I can imagine. So, hey, you know what, though? We'll have an update later on. We'll circle back around, maybe have a little side podcast about fun pranks and ideas you can do for your friends over Zoom to lighten things up. So, honestly, I like this. We'll revisit. Okay. But with that in mind, then, like what we're kind of talking about, the magic of science here, chemistry that really tied you into a lot of this. So I'm curious then, kind of tying into your career and kind of how you got into the science field. We know that you did some pretty cool stuff in grad school with nanoparticles and solar panels. So can you kind of dip into that magic, if you will, and talk about what that was like?
Sure. So my PhD is in nanoscale science. So I studied different types of nanoparticles for solar panels. So obviously, nanoparticles are really small. So you can make an extremely thin solar panel, like almost like a skin on a building, and it'll be transparent, but it still works the same. So specifically, I worked on gold nanoparticles paired with quantum dots, which it sounds really crazy, but it's really these tiny particles that you act like as an antenna to make the sunlight way more focused into the device than it would normally be. So they're much more efficient than conventional silicon solar cells.
That is so interesting.
Fascinating. So could this actually be like a wrap on a building someday? Like if it was ever scaled and instead of having these huge panels?
Yeah, absolutely. And they even have like self-tinting windows because it can be transparent, but when the sun comes out, it'll tint and it'll absorb even more light. There's a lot of stuff in the works, but unfortunately, like you said, it's not scaled yet. And nanoparticles are pretty expensive to make and characterize and buy. So hopefully, we'll get past that.
Yeah, and imagine, gold has a little expense to it too.
Yeah, even nano gold.
Even nano gold. So you had an internship with AFRL. What type of internship did you have, and what all did you do during it?
The summer before my last year of my doctorate, I did the AFRL Scholars Program, which is just a 10-week summer internship. I highly recommend it to everyone, even remotely interested in what it's like to work in a DoD lab, because otherwise you really don't know what it's like because it's all, so under wraps. So I actually worked on using gold nanoparticles as a color changing detector for chemical warfare agents in the air. So they'll actually change color based on what's around it, which is crazy. Obviously, unlike any normal bulk material, like gold's going to look gold no matter what gas it's around, like a bar of gold. But nano gold will change the whole spectrum of the rainbow, depending on what's around it. So basically, we're trying to work on making a chip to do this chemical warfare agent sensing to replace maybe the moth antenna in this helicopter that Melody Anderson and Jennifer Talley is working on, or even just replacing the handheld gas detector that, first responders and warfighters have to walk out in the field with, which is incredibly dangerous for them, I'm sure you can imagine.
That's wild. Like, I'm trying to think, I'm speaking out of my depth here, of course, but thinking about what you just said, that gold won't really change, at least in terms of, let's say we have visible gold like a bar in front of us, not going to change pallor depending what touches it. But nano gold does. Like, I've heard that, especially in the quantum world, the smaller you get, the stranger things can be. So, like, what's kind of the science behind that then? How does it change colors? Is it just the nature that it's so small, or what is it?
It is. It's the size. So the size determines the color, but also what's around it determines the color. And that's because it's so small that the electron cloud around it extends past the surface of the material itself. So that electron cloud is actually being affected by what gas is around it, and that causes it to change color. So that's awesome. Like what quantum is. Quantum confinement is when the actual surface of the material is smaller than the electron cloud.
Yeah, I'm trying to get my head around that. As small as it is, it's so neat to hear anything about the quantum world, anything about how it interacts. It's just every time I think I learned something, I learn either the opposite or there's so many more capabilities than I could have imagined, which is awesome. So with that in mind, these capabilities, like a lot of the work you did with these nanoparticles, especially with AFRL, what are some of the real world applications? You mentioned they have detecting different materials around airmen, but for instance, let's even outside of that, what could that be used in civilian life?
I just wanted to give a little shout out to this really old famous cup from 4th century Roman times. It's called the Lycurgus cup. You should look it up. They accidentally made a nanoparticle glass. So it's this cup that if you look at it from the inside, it looks red. And if you look at it from the outside, it's green. And that's because there's gold nanoparticles in it and they scatter green light really well, but they'll transmit red light. So anyway, that's really cool.
That's awesome.
And yeah, it was like an accident. Apparently it's like with the forging process, somehow they created nano gold.
Yes, to strike gold literally that long ago too, to think about that, especially with a lot of the forge techniques of that era. So is this something that they'd found and researchers here had realized hey, wait a minute, we're doing similar research. Can we see that cup?
Exactly. Yeah. They're like, oh, that wasn't magic, but it's still really cool.
Seems like it.
Sorry, back to your question. there's quantum dot TVs. So they work the exact opposite as a solar panel, where you harvest light and turn it into electricity. Well, with a LED or quantum dot TV, you actually give it electricity and it emits this beautiful light. So they're like really sharp displays. And there's a lot of research with nanoparticles in the medical field. One of them that really is awesome, and it's already being used in human clinical trials, is photodynamic therapy for cancer research. So for cancer treatment, actually. So they'll actually inject like safe nanoparticles into the body. And instead of pumping your whole body with chemicals that'll kill any cell in its path, they only become deadly when you shine light on them, a certain wavelength of light. So what they'll do, it's normally for like skin cancer, stuff that's close to the surface, and they'll shine light on it, and then it'll, oscillate really quickly and kill only the cells nearby.
Wow, so it actually targets where you put the light is where the damage will occur. You can target those cells only.
Yep, and because of their small nature in general, they're actually attracted to inflammation. Like they love little nooks and crannies, so they will actually target a tumor naturally anyway. But like you said, they're only deadly when you shine light on them.
How world or life-changing could that be? We had a podcast earlier about microbes, and after that podcast, I was just like, oh my gosh, microbes are the coolest thing. And now it's like, but are nanoparticles actually cooler than microbes? Things I don't know. Well, I'll make a judgment call at the end of this podcast. How about that?
Yeah, that's the big debate now. I'll put that up here for the viewers as well. See what you sound off in the comments, if you will. But something that I want to go back to a comment you mentioned beforehand was when you joined this internship with AFRL, you said a lot of people don't really know or have a perception of what it's like to work in like a DoD lab or a lab space like this. So what was your perception before going in? Like, what did you expect this position to be like with that kind of in mind? Thinking about almost like a lot of the nature of government work seems so secretive.
Yeah, I think my biggest concern and preconception about it was working with a bunch of old guy scientists that won't take me seriously or potentially be homophobic because I am a lesbian. But that was not the case at all, honestly. That's what I expected, and I shouldn't have. But no, it was awesome. There is red tape like you'd expect, but honestly, it's worth it. I love the nature of the work. I love the pace of the work. I love the impact that you can make in the world instead of just, making a company profits. You have the ability to like protect people and help people. So I like it a lot.
That's great. Yeah, that was my follow-up question was how did that change? And I'm glad to hear you found a space that you said you could really find research you love and people who are like, hey, like Kathleen's awesome, bring her on in and get to hang out and really do some cool work with nanoparticles and connecting even further now, your work with alternative navigation techniques. So I know we've talked a lot about like the cool stuff you've done with nanoparticles, but I have, since we've started, been very curious as to what alternative navigation techniques are and how that kind of relates with what we've talked about. So can you kind of talk about your position and what literally led you to it?
I basically work on alternative navigation techniques, specifically synthetic aperture radar and celestial aided navigation when GPS isn't available. And I know this is completely different than what I worked on before, but hey, as an undergrad, I did salamander research. Like that's just the nature of being a researcher. For me, at least, I love learning about different things. But I knew I wanted to stay here. I love Destin area and I love the people I work with and the support that I have here, especially with AFWISE as a woman. And I told, my supervisor that, hey, like, I really want to stay here. Is there a slot open? And there was, but it just, wasn't in my field. And I just decided, okay, I'll do it. I'll learn and I'll learn about a whole new field. And I did, and it's been awesome.
Yeah, I know with that, something we talked about before, and I think it's really cool you touched on is being a researcher, how many different things you can touch on, whether it's salamanders, talking about nanoparticles, navigation research. I mean, there is such a wide spectrum of stuff you can focus on. But what was it like that learning curve? Like, was it pretty intensive, almost like doing a new course, if you will, trying to connect to what it is to be a navigation researcher versus nanoparticles? Or like how much work did you have to put in to prepare for the position?
A lot. There was a decent curve, but I A lot of other people I know that are like super nerds like I am, like it's fun learning about something new, especially something interesting. Like I find it really interesting. So it wasn't hard to want to learn more about it. But yeah, I'm actually like, I took courses to get ready for this job.
But like you said, that's fun. Like it's a way to get back in there, learn more, and really expand that breadth of knowledge, which is awesome. You could find something that's so unique and so cool. So now that we've kind of discussed like how you got to this point, I'd love to learn more about it. So what makes the work you're doing so important to pilots, and how's it really changing, I guess, the way that they're flying? Like how is this different than what we're used to, let's say, in the past decade or so?
So global navigation using satellites is great, but unfortunately, it's very susceptible to jamming, cyber attacks, and even just limited sight affecting it. So what alternative navigation techniques, hope to accomplish is give us high confidence in our location without relying on GPS signals that could be damaged or degraded.
But we don't expect the pilots just to have navigate by the North Star exactly, do we? You mentioned celestial stuff. They're not up there with like a map and, my Girl Scout handbook that I had growing up that told me, where Ursula Minor was or something like that. What are they working with?
I know, that's so funny you say that. When they first explained to me what celestial navigation was, I was like, so like Harriet Tubman, she was doing this a long time ago, but no. Yeah. It's actually using any, space objects like, satellites, space junk, and there's catalogs of it, of course. And you know where it's going to be and when it's going to be there. So basically you can like take a picture of the sky, and then from that point, about where you are. So it's not really using stars. Stars are too far away to actually use because they don't change much when you move a lot.
So it's kind of like picturing this. So I take a picture of the sky and identify different satellites or junk or whatever bits of rock or pieces of things that have broken off. And this big database knows where it should be at a certain time. And from my position, I should then be able to figure out where I am on the planet or on the air above the surface.
Yeah.
So you guys really put it together well. That's a really cool way of visualizing like how this all works, like picturing the heavens literally and finding out where you're at. So the question I had with that then is something we kind of talked about was how this could work. And with a pilot up there, would this be the case that let's say that they may need assistance in actively getting back on track? Would this device take over, or would this be more something along the lines that the pilot simply just takes controls themselves, realigns, and they're solid?
So normally in a navigation system, there are a bunch of different sensors working together the whole time. But, there's some that are much more reliable than others. So, a lot of these sensors are already there. Like for, synthetic aperture radar, like there's a lot of that stuff that's already there, but we want to make it reliable to the point where it can fully take over and we can use that with confidence, when stuff's degraded or jammed or, attacked.
Yeah, no, that makes sense. Yeah, I was wondering how autonomous it was. That's very cool to hear it has some capabilities. And going down that train even further then, is this technology planned on being used in autonomous vehicles themselves? Let's say drones or other monitoring aircraft outside of manned systems?
Oh, absolutely. Yes. But of course, there's the caveat of it's small, so you need a low size, weight, and power type of sensor to be able to fit on that platform. But absolutely.
And something I was curious about this as well, because it's so cool how expansive this technology is. Like, again, like you'd said, working in different unmanned aspects, working in manned aircraft. In terms of testing then, I imagine that a lot of this is just all simulated work then? Like you have a cool computer station, you can just run simulations, kind of check it, give it thumbs up, or how does that all work?
Well, we do simulations, but plenty of flight testing as well. So real flight testing and where we turn the GPS off, but we know the truth. And you can compare.
That's awesome. So it's great to hear that this is moving along, and hopefully we get some more updates later in the future when we hear more about it. But this is the first time I've really heard about technology quite at this level. So that's some exciting stuff.
Oh yeah, thanks. I really love it. It's awesome.
I'm just wondering, from like a love of science perspective, have you gone down the rabbit trail to learn about like quantum navigation, or just studying, how animals seem to navigate around the globe, and they don't have, little satellites up there, but, they can find their way home in migration patterns?
Yes, that's such a good question. So the bio-inspired team, which is not the team that I'm currently on, that's the team I was on for my internship. They are, they're studying bees. Bees have magnetic nanoparticles in their bodies, and they use those nanoparticles to orient where they are on the earth. There's plenty of examples of nature navigating, not using GPS, really well that we're studying, and we're trying to see if we can like make a device similar. Butterflies are amazing at it as well. In birds, they have like cryptochrome in their eyes. In addition to, some of them have magnetic nanoparticles in their abdomens as well. I'll have to check on that, but yes, that's a great question.
Okay, I had no idea that was going to tie back to nanoparticles again. So they're winning in my book. This is really cool that a bee just has, magnetic nanoparticles just hanging around.
Yeah, absolutely. There's some animals that actually produce them. I know that there was a type of bacteria that can produce silver nanoparticles, which are antimicrobial, to kill other things around it. Which I was like, what? That's crazy.
Oh my gosh. I feel like, Spider-Man, like you got, Peter Parker, right? Is it Peter Parker, Ken? Is that his name?
Yeah.
Yeah. And also Miles Morales, there's plenty of others in the Spider-Verse, but he's our main guy.
What if you got like stung by a bee? Then all of a sudden you could just navigate anywhere. You didn't need to know, I don't know, just thinking like instead of being a spider bite, I don't know. We write comic books on the side, Ken. We've got an idea.
And hey, there's a lot of people. I mean, to a lot of credit of that, there's cool stuff with Daredevil. He's able to not use nanoparticles, but he can see the world around him through sound waves. So it's kind of cool to think about how many animals not only inspire our favorite comic heroes, but with what Kathleen's saying here, like hearing a lot of this research, it is amazing to think everything we've done, the animal kingdom has either found a way or perfected it. So we just study that and get all the answers we're looking for in many ways. I had no idea bees had that. I have to imagine that's more of a recent discovery, or maybe not. I don't know.
I'm not exactly sure when that was discovered, but I do know it's like a kind of a newer area of research to study them and how they magnetically navigate to help us use the magnetic anomalies of the Earth's crust. Because, there's like iron ore in different places, and that's like just as good as a geographical map. So we can actually use the magnetic map and like use that to navigate. It's pretty cool.
Yeah, because I would have guessed, I know the classic example has always been carrier pigeons and other birds that have like that magnetic sense where they know where they're at all times. But again, bees had no idea. But that it's so cool again to think even with advanced systems like this, even working in the quantum world, we can still look to nature for answers. And I'd forgotten that you mentioned that you worked with the bio-inspired team. So a lot of that research had to really like almost getting up to this point, that really had to help you out because you have to think about everything that's touched by nature. You're like, yeah, I've worked in this world. I know how this works. And it's kind of cool to have that basis almost before you moved on in your career.
Exactly. Yeah. It's been great. And even just thinking about cross collaborations between teams, like I know what's going on over there. So it's easy, to bring people together and think about people that could help.
And speaking of people that can help, something you mentioned beforehand, I really wanted to get a full purview of your career before we kind of dove into this. You mentioned AFWise, and that's something we've actually had a podcast on that'll drop before we talk here about it, and talk about the impact of some of the chairs who are sitting there currently, the current chair and a past chair, and just how important that is for women, especially in AFRL, and the impact it's had in their career, helping illuminate a lot of areas they may not have known, or even helped out in spots that people didn't know where to go to ask these questions. So I wanted to ask when you came in, and you mentioned beforehand, especially being like, a lesbian and a woman here in STEM, how has AFWise helped you and how important has that been in your career?
Yeah, so I joined AFWise 2 years ago, and it has provided so much awesome support, just being a gender minority in this field. And we have awesome speakers that are super motivating, and they, of course, told us about like different women right now in leadership roles. Like my team lead is a woman. My first level supervisor is a woman. The commander is a woman. And they're not just women, they're amazing at their jobs. And I find that extremely empowering and motivating because you can see someone who's like you, kicking ass at their job. It's awesome. It's extremely motivating. The gay thing, though, at the time when I started the internship, I like made it a point to be like as out as I could, just to get a feel for like, are people, going to be weird about it? Are they going to accept it? So like, any natural chance I could, I was out. And lucky for me, like no one was weird about it. No one made me feel awkward or, like I was being judged, which is awesome. And I kind of highly recommend doing that if you're comfortable and gay before you like start a job somewhere, because, in some places you're like allowed to legally be fired for being gay. So, but which brings me to my next thing. Last year was the first ever council for LGBTQ plus people on Eglin. It's like a club, and we like plan and host like pride events and all sorts of stuff like that. So it's allowed me to connect with a lot of other LGBT people on base and allies, which has been awesome. So that's helped me a lot.
That is awesome. Like to hear, especially that Eglin has that support, especially in the STEM community, a place to meet. Like, I know you and I talked about it before, but I mean, huge shout out to my mom, Karen Morgan, great person. So she has been married to my mom for years and very similar, has done a lot of outreach efforts here in the Cincinnati area to do just that, helping people in STEM. She's an engineer to really find and connect. And that's so important, especially if you're in the LGBTQA plus community. To find, like you said, similar people in the your career field or people to talk to. So I'm so happy to hear that you guys have had that accepting community, chance to get your voice out there and to be your true self. Like that is so hard for some people. And this, especially this podcast, that is very empowering to hear.
Yeah, it's awesome. I'm so lucky that like right after I started here, I got the email that they were putting together this council for the very first time. I was like, I'm honored to be a part of it. So it's great.
That is great. And going along that then, so I know AFWise has been a really good, like, and especially this community you've been part of has been so great to actually help you feel empowered, as you mentioned, to meet more awesome people. And how's that helped you be more of a leader in like the STEM community? Like you feel this has given you more tools for outreach for younger audiences or even people who may have questions that you now have answers to?
I think it's important, of course, to have people to like that you look up to, and AFWise has really helped me find those people and also like feel supported. And of course, like it's given me great ways of supporting other people. And not only all of that, I do think it's really important to always act as if you're someone that someone looks up to, even if you're not, at all times, just because you just never know who's watching you and who, I don't even know if I answered your question, but.
No, you did. And I really liked what you said there. Act as like, somebody who you'd want to be somebody to look up to. I just said that weird, but you know what I mean? Like act like the person you'd want a mentor to be like,
Totally,
and that was exactly what I wanted to touch on is like, has this helped you become a better mentor, you think, or at least be able to help out younger generations interested in STEM?
Absolutely. And I'm actually a Lego League judge. It's like I think it's middle school age kids, it's a robotics competition. So I was like a science fair judge. So my job here, working with Brian Mitchell, who's our outreach coordinator, it's given me so many opportunities to just do community outreach and just be like, hey, like, look at me, I'm a young woman and I'm a scientist at AFRL. You can be too. It's meant a lot to me. It's really important because my parents never went to college, so I had no exposure to that. And, things like demos, things like outreach is like, can make or break someone's interest.
But I mean, it sounds like you're so passionate about what you do and so excited. I mean, at the top of the podcast, you're talking about, I just keep, some chemistry experiments around the house in case I want to inspire some kids to think science is as cool as you did with the elephant and toothpaste experiment. And you're a science fair judge, Lego League judge too. I mean, final question is, do you have any advice for those students and maybe in those minority students that are looking to join the world of STEM? What would you tell them?
Do it. Do it. Whether you're like a racial minority or a gender minority or, any kind of minority, even though, we might not be as diverse as we could be right now, I know firsthand that AFRL is making a huge effort to support minorities and like provide support for minorities in general. So we're working on it. We're trying really hard. There's a lot of awesome people who have already paved the way for us. And it's not as bad as you think maybe it could be. So just do it. We need you. And, if you're not sure or you want to feel things out, try some either AFRL scholars internship, try some sort of internship involving us and get a feel for it and learn for yourself how great it is.
Absolutely. And if we've got students listening or their parents or mentors, or they're just an adult in their life, you can check out a lot of those opportunities at afresearchlab.com. So Kathleen, I want to thank you for joining the podcast today. It was a lot of fun. I think I need to spend my evening reading more about nanoparticles.
Yeah. Well, thanks so much for having me. It's been a blast.
Make sure to follow us on social media at Facebook, Twitter, LinkedIn, Instagram, and YouTube at AF Research Lab. And remember, stay curious.
Logging off.